What up, 7th graders? Today's lesson is 1.2 microbiomes. So you guys kind of got a little taste about how I'm going to do some of my amplify assignments on our last one. So hopefully this is kind of getting you guys a little bit more used to the little patterns you guys will see with my assignments and how to navigate them. All right, so your lesson today is 1.2 microbiomes and your learning targets for today. I can explain what a cell is and describe how small it might be. And I can identify how small a micrometer is and how that relates to microorganisms. So when we start talking about things like bacteria or even viruses, when I tell you guys how small they are, you guys kind of have an idea, if I were to scale this out on a ruler, what that might look like. All right, so for your guys' bell ringer today, you guys needed to do two things. The first of which is activity 1, your notebook. Okay, you guys needed to add key concepts 2, 3, and 4 to your notes, as well as add cells and microscopic into your vocab. So it should look a little bit something like this. Notice I have cells and microscopic right here. Cells are the tiny structures that make up all living things and are the smallest units able to perform life functions. So we've talked about organisms being only one cell, whether that's something really small like a bacteria, or if that's a larger organism like amoeba, that's still only one cell. But either way, those two organisms can sustain on their own with just living the life of one cell man. All right, and then microscopic is too small to be seen with the naked eye. You guys were also to add key concepts 2, 3, and 4. So those are my larger ones right here. All living things are made up of cells. We learned that when we looked at the 7 criteria for life. Okay, almost all cells are microscopic. We have some exceptions to that. For instance, a muscle cell is actually a lot of muscle cells that have fused together to form one big long fiber, which we still consider a cell because there's only one cell wall around that. And then finally, key concept 4, even though they are both too small to see, cells are much bigger than molecules. And again, when we talk a little bit about scale and we see that scale tool again today, you guys are gonna see like a water molecule and how small that's kind of on the nanometer range, which is 1/1000th of a meter stick. Okay, versus cells, you know, we can see those a little bit better under a microscope. They're a couple depending on what cells they are, but they're, you know, a couple micrometers long or whatever the case. Okay, so we'll come back to that when we talk about our scale tool today. All right, so once you guys have those in your notebook, you'll move on to activity 2, which is your warm-up. Remember, as you guys work through this from home, pause this video after each little activity so you guys can complete the activity when the directions are fresh in your mind. And then when you're done with that slide or slides, you guys can go ahead, pop back into this video and get some instructions for the next activity. All right, so for your warm-up today, you're gonna need to use a draw tool. So I'm gonna click up here to the draw tool, and then I'm going to click some kind of pen or highlighter. It's up to you guys. What you guys have is 5 statements. A, cells come in different sizes and shapes. B, all organisms are made of many cells. C, some organisms are made of just one cell. D, all cells are the same size and shape. And then E, most cells are too small to be seen with the naked eye. You guys are going to use your draw tool to choose all of those that you think are true. I obviously just highlighted all of them to show you guys what that might look like. Doesn't mean they are all true. So I'll let you guys kind of figure that out. Just a reminder, anytime you guys use the draw tool, it's really important that you click back on your cursor. Otherwise, you're gonna find that you're trying to click here to type your answer for the next question, and it's not gonna work. Remember too that anytime you guys see this question mark, there's something you need to do on that. And like I said, sometimes I'll try to include weird little bitmojis of me to indicate, hey, there's something you guys need to do here. So make sure you guys check each side carefully, especially when you see this question mark, to make sure you've done everything. A lot of kids will miss doing the draw tool part. Okay, and then answer this question. What else do you know about cells? Record your ideas or any questions you have about cells below. So you guys will need to click and answer, I know, ... Okay, so tell me what else you know about cells. Writing, I don't know anything is not an answer because you guys have already learned something from listening to me talk. Okay, all right, moving on to activity 3. You guys have a little video called How Small is a Cell? So you guys will need to pause this video. You guys can right click, open the link, and your little video that you're gonna watch looks something like this. How small is a cell? Go ahead and watch that, and then when you guys are done, you guys can come back into this video and I'll explain the next activity to you. All right, so you guys should have just watched How Small is a Cell. we're going to go ahead and look back at our card sort that we did the other day. So if you guys were in class, you guys did this with the actual physical cards. We have the answers up on the board still. We went through and kind of ordered them correctly. Obviously, if you guys were gone last week as well, or for yesterday's assignment or the last lesson, however you guys want to look at it, we went through this as well. So this is in 1.1 microbiomes. I gave you guys kind of what we put together in class and then in the last assignment for you guys to see. All right, we had a water molecule is the smallest out of all those objects that we looked at, width of a DNA strand. In between there, we had about 1 micrometer. E. coli is a couple micrometers. Human blood cells are bigger. Human skin cells are even bigger. And then this was kind of the line between things we can't see unless we use a microscope and things that we can see with the naked eye. Okay, so a width of a human hair, salt grains, an ant, 1 centimeter is kind of here between an ant and a marble, and then a human being. Okay, was our biggest out of those cards. Obviously not the biggest thing we have, but you guys will also see that kind of stuff in the scale tool link, which is included right here. Okay, so what you guys will do on this is I have given you 3 more cards to kind of try to figure out where they go in this little size line or timeline, however you guys want to look at it. Okay, so what you guys will do is you'll need the draw tool for this. You guys can do like 3 different colors or however you want to do it. I'll kind of do C. difficile for you guys. What I've included on this is a size of how big C. difficile is, and we're going to start talking about this type of bacteria called C. difficile. It's a very harmful bacteria for humans to have in their gut. So we're going to kind of figure out why is this important for us to learn about. But what we do know is that a C. difficile bacteria is about 1.8 micrometers in length. And then we have all of these ordered. So we know we're going to kind of be in this range of things we can't see, microscopic things, but we want to know exactly where that's going to go. So what you guys are going to do is you're going to right-click the scale tool link and open that up. Remember you guys had this little thing where we could drag. Okay, and what we're going to do is we're going to go down to our small things. We know it's 1.8. So we can look right here and say, all right, here's 1 micrometer. Oops, I passed it. Okay, 1 micrometer is about right here. So we can take a look at Streptomyces griseus, which is a type of bacteria that we find in the soil. It's about 1 micrometer. So here it is right here. And then right above that we have E. coli. Sorry, it's kind of hard to see. Little E. coli bacteria. If you guys need to, go to the 3 dots up here and zoom out. So here's E. coli. So we can kind of use that in comparison. So we know that C. difficile is smaller than E. coli, and it's definitely bigger than DNA. If you guys are unsure of that, we can go down and say, all right, where's DNA at? Here's DNA right here. So that's 2 nanometers. That's really small. Okay, so we're going to go ahead and we're going to draw a line and say, all right, this is my C. difficile. It's going to go right here in between 1 micrometer and E. coli. Okay, then I can do a different color for my human liver cells. Okay, maybe I do orange. You guys can choose. It's up to you. So go figure out, human liver cells are about 40 micrometers wide. So you guys can figure out where it fits, draw a line, show me where it fits. And then here's ringworm. It's about 5 micrometers. So you guys can use a different color. And then draw in there, show me where that fits in as well. Okay, remember again that when you guys are using your draw tool that you guys click back on your cursor, otherwise you're going to have some problems. Okay, moving on, activity 5, I have a little video that I made for you guys just to kind of give you guys an idea how small is small. So when I say micrometer, how small is that really? So you guys can go ahead, open that link up. Okay, it looks a little bit something like that. Excuse my messy hair. I made that a year ago when I was dealing with teaching and COVID. Not like it's any better now. Okay, pause this video, go watch that, and then come back and we'll look at our next section. All right, so now you guys have a little idea how big a micrometer is. I mean, could you guys imagine drawing 1,000,000 little lines on a meter stick? Okay, that's small. Okay, or even 1,000 little lines in between those 2 little millimeter lines. So that's really, really small, especially when we're talking about things like C. difficile, which again is a bacteria that we're going to reference a lot. All right, on page or slide 7, you guys have activity 6, which is reflect and read. You guys are going to use your draw tool. You guys are going to kind of revisit what we did in our warm-up. You guys have a little bit better information now to back you guys up about what cells are. So go ahead, highlight ones that you guys know to be true now. And then make sure you click back on your cursor, because for the next slide, you guys are going to need to right click. Oh, see, I didn't click on my cursor. You guys are going to need to right click this article right here called cells, and you guys are going to open this up. Okay, so you guys are going to be reading this article called cells. Okay, it's kind of lengthy, but I have a deal that I make with all of my students. Okay, I don't want you to annotate and highlight. Okay, I'm going to say that again. I don't expect you guys to annotate and highlight. If you want to do that, you may. But I do expect you to read it. And if at any point I feel that you guys aren't reading these, then we're going to go back to the old-fashioned, show me you read it. Let me see your annotations. Let me see your highlights. Okay, so go ahead, read through this article. One great thing about Amplify is you can click this little speaker right here. Maybe you just struggle to read. Maybe you want a little help. Maybe you listen better and you hear things better. You guys can go ahead and click that and hit play.
Cells, the basic unit of life.
And you'll have this really monotonous voice read you guys the article, which is fine. Sometimes it's easier to follow along if you guys have something reading to you as well. Okay, so read through that article, and then you guys are going to answer this question. What is one new thing you learned about cells from this article? Again, nothing is not a response. If you didn't learn something, then you need to go back and read it again, okay, because there's something in there that I know you don't know. Okay, and then answer these two questions about your article. What are organelles and why are they important? That comes directly from the article. You guys can reference back if you guys need. Okay, I'm going to assume it's in all this part that talks about the organelles. Okay, and then how are cells, tissues, organs, and systems related? So answer those two questions. And once you guys are done with that, we can go ahead and work into activity 7. This is called More Scale Fun. For this, again, you guys will need to right-click and open the Scale Tool link, which I shouldn't have closed out in the first place, so hopefully it loads quick. And you guys are going to read through this. Today you've learned the following, that living things are made of cells, which you knew that before this. Cells are very small. In fact, almost all cells are microscopic, and some living things are made of just one cell. Think about how the scale of cells compares to the scale of other objects. So you're going to launch the scale to and complete the table on the next slide by finding examples of objects at each scale that is listed. Some parts of the table have been completed for you, so that'll kind of give you guys an idea of what you're looking for. So on the left column, you guys will see the scale. It tells you guys how big something is. So for instance, on this first one, we'll kind of do together. You're looking for an object in that scale tool that is thousands of kilometers. So I'm going to go up to my scale tool here, and I'm going to click and drag this. You guys can kind of see, here's my meter. Here's a tree. Let's see how big that is. That's only 100 meters. We're looking at thousands of kilometers. So we're looking at kind of like miles almost. So I'm going to keep dragging. All right, what is this? This is the Grand Canyon. All right, here we go. Grand Canyon is 1,800 meters. So if we're looking for thousands of kilometers. So I'm going to keep going bigger than that. Okay, here is the Mauna Loa volcano. That's still in meters right there. This is the Olympus Mons volcano on Mars, is only 22 kilometers, so we're going bigger than that yet. Okay, let's go to our next object is Pluto. So there we go. There's something that is thousands of kilometers. So we can go ahead and say object at this scale, and we can type in Pluto. Okay, there might be more than one option if we look a little bit bigger than Pluto. Okay, the moon's thousands of kilometers as well, so that would work. Mercury is also a couple thousand kilometers. Titan is a moon of Saturn. Mars is thousands of kilometers. Earth is almost at the tops of our thousands of kilometers. So you really could pick any of these planets as your scale tool. I'm going to go ahead and stick with Pluto and say, all right, object at this scale is going to be Pluto. And then the size of that object, we're going to look and say it is 2,300 kilometers. Okay. And then thousands of meters, you guys are going to look at the depth of the Grand Canyon. We kind of already passed that, so go find the Grand Canyon. Tell me how deep that is. Meters is already done for you guys. You can see an orca is a couple 8 meters. Centimeters, so go find an object that has some centimeters, that it's measured in centimeters, and then micrometers and nanometers. So you guys are kind of taking and gauging down from there, okay? All right, and then you guys will see nanometers is kind of as small as we're going to talk about in science, but there's even smaller than that, okay? All right, so you guys will complete this as well. And then we're gonna move on to our homework for the day. So this is kind of getting us started in what we're gonna do in our STEAM when we're starting to do the out of sight, out of mind, the bacteria growth experiment. This is a Petri dish. And what these scientists have done is they have cultured a bacteria on this Petri dish. And this is a picture that's taken on the exact same day that they added the bacteria to this. So they added the bacteria and then they took a picture of it. So your question that you guys are going to answer is, can you see evidence of microorganisms? I'm not asking if you think microorganisms are there, but can you see evidence? Use your draw tool to circle yes or no. Describe what you observe in the Petri dish. This is going to be something that once you guys get your microorganisms plated come Wednesday, that you guys are going to have to give a good description every day and for a week. Okay, so make sure you guys do a good job practicing here. And then what do you think the Petri dish will look like on day 5? So if we let this sit in an incubator for 5 days, what do you think it might look like? Okay, go ahead, complete your wrap up. Any questions, yes or no? If you have any, type them below. And then 4, 3, 2, 1, how do you think you did? That is a mandatory thing to do. And now you are all done for today. Don't sweat the small stuff. Have a great day. And don't forget to hand this in. Talk to you later. Bye.